Yeah, so hi everyone. My name is Nino, I'm a product lead at Oasis, and today I'm gonna talk a little bit about programmable key management and how it can reshape the DeFi infrastructure and how it can affect DeFi in general. I'm gonna do two tiny announcements, so pay attention, we're building something new, and I think it's super interesting. Before we start with the juicy stuff, first we need to slightly review the landscape. So what have we built so far, not only in Oasis, but more generally in Web3? We built multiple really good tools, like multi-sig, multi-party computation, ERC-4337, and smart wallets, but all of them have something in common. So whatever you do with those tools, it's mostly visible on chain. It requires some sort of coordination between people, right? So imagine multi-sigs where you're waiting for that last signature to meet the threshold and it's not making it. They're super chain isolated, so we have silos. What works on Ethereum doesn't necessarily work somewhere else. And obviously, they lack the privacy. It's not part of the solution. In order to build something new and to draw the idea from something, we cooperated with Cornell Tech, which provided a research paper where they coined a new primitive, which is called key encumbrance, which means a private key that essentially is born within the TE enclave, and the only way you can access this key is over programmable policies. So this key inside an enclave is never essentially available to anyone, not to you, not to delegates. Over programmable policies, what you essentially access is the signature, not the key itself. So once we understand this abstract term of key encumbrance, from it we can also think about liquefaction, another very abstract term, but this essentially means you can privately unlock assets and trade them without the intent being discovered or visible in the mempool. All right, so we had the document from Cornell. It also came packaged with some of the use cases, and we were thinking, how can we implement this kind of approach with Oasis? Obviously, Oasis being the OG in the TE space and confidential computing. So we attacked the architecture from the angle of the key lives inside the TE. We attach programmable policies, which a user has to pass or the intent has to pass in order for the key to get decrypted and essentially sign the transaction on the target chain. Now, this kind of setup does not require approach like multi-sig. You don't need a quorum. It can be only one vault, multi-policy scoped actors, so you can essentially also work alone under certain condition. How encumbrance compares to existing multi-sigs? Privacy with multi-sig is obviously on-chain, so a lot of the actions or most of the actions are visible on-chain. Multi-sig is locked to a single chain. Typically, coordination requires quorum. Enforcement is contract-based. If you want to delegate something to someone, you are adding and removing signers or even signing in order to add signers, so it requires a lot of work, and it is not super composable. On the other hand, encumbrance, because it's happening inside the TE and you have to pass the programmed policies in order to access the key signature, those limitations are no longer present. So without further ado, I would like to introduce Flex Vaults, which we call encumbrance-powered vault infrastructure for DeFi, and we're going to look into the infrastructure. So at the top, we have a user layer. This is where your dApp would sit, and you would talk to the Flex Vaults over the SDK. We're going to get slightly into details that Flex Vaults are more than just an SDK. It's a full end-to-end service, but for now, let's pretend there's only the SDK. The intent or what you want to do with the key is then passed into the enclave. So whatever we see here with a blue stroke, this is all inside enclave, and it's composed from the policy engine, a private key that was essentially born inside the enclave, and transaction executor. So your request first lands on the policy engine, which is stored in the smart contract. It is compared whether this request can pass the policy engine. If it passes, the key is then used to sign the transaction. So maybe just to put it more plastically, even though Oasis is its own network, you are not depositing your assets to Oasis. Instead, look at it as a smart container, confidential container, where you generate the wallets for target chains. And you can sign with them over programmable policies. Transaction can then obviously be executed on any blockchain, whether it's smart contracts or we're actually moving user assets. The second thing I would like to announce, so as we started building FlexVault's SDK, we figured out the key encumbrance and liquefaction. We were thinking, how can now Oasis also participate at the application layer, right? So far, Oasis did a lot on the protocol level or more on the development side, and we are now thinking about products and building products which will have user-facing interfaces. So one of them is FlexVault as a full service, on top of which we are also adding 2 microservices for the MVP, which means trade and earn. And it will essentially allow integrators or users to do fully private swaps across DeFi or DeFi aggregators such as LiFi. As I said, FlexVault's more than an SDK. We're also coupling it with a trading service and an earn service for the MVP. And what is interesting thing that we're currently exploring, and it's already getting built, is that when an intent comes to the FlexVault's SDK, let's say your user wants to swap Ethereum for USDC. How we want to do this is we want to explore 2 paths. And the first path is the internal settlement, which means we can have a TE ledger, which is completely, living inside the confidential space. And if this specific trade moves in the direction where it's, someone else is already waiting, or maybe even Oasis can have its own provisioned liquidity, we can execute this immediately in the stage 1. So literally, it's an accounting change within the TEE. If the step 1 or if the path A fails, well, then we're doing DEX routing. So think of it as a pass-through. Essentially, the signature for this intent happens inside the enclave, and then we can route it to LiFi or any other DEX. Where essentially, because all of the users are depositing into the same vault, we keep their intents obfuscated to the mempool. So when we think about policy engine, and I was talking about it quite a lot, but maybe let's put it more into a DeFi context. So what could you do, right? Because everything is self-enforceable inside the TE, you can start thinking about policies such as spending limits, token whitelists, maybe trading time windows, protocol whitelists, revocable access, right? So if we again compare this to a typical multi-sig, it would require you to have a quorum in order to add someone to the signature, and then after a certain time expires, you would again need quorum to remove that additional signature. Here you can simply program it and say, after 30 days you'll no longer have access, and because the private key was never shared, this rule is only enforceable over the programmable policy. Lastly, I want to talk a little bit of the use cases. So if we're talking about intent-based private trading, this is a quite popular term right now. We're trying to build solutions where sandwich attacks are no longer happening, where maximum extractable value is no longer a problem. And this is possible with FlexVaults. So the intent gets signed inside the TE. and intent gets obfuscated to the mempool, and privacy becomes structural, not a relay layer. One good use case is, imagine a TWAP algorithm which is running across DEXs. You're trading a substantial order, and typically you want this to be hidden to the mempool so that you can actually execute well. So in Flex Vaults, this means you can deposit into Flex Vaults, run the TWAP algorithm, and the only thing that is visible to the outside is essentially every trade going out and the finality, but there is no clarity on how much you are actually dumping until you are finished. At the same time, keep in mind that from the same vault, other trades from other users are happening as well, so obfuscation achieves another level. I mentioned early on that besides the trading service being bundled into FlexVault SDK, we're also providing the Earn microservice. And I think here we are basically starting as a pass-through service, but you can still have your privacy. The idea is, and I will talk about it a little bit later, in the composability state. Maybe I will show a use case for this. So in our product built on top of FlexVaults, which is user-facing, we are also introducing rules or automation rules, which for the first time in DeFi are allowing non-custodial automatic execution. And for this, we are utilizing the programmable policies. So how you can imagine this working is you have certain assets in your bags, and you can configure a rule which monitors your, let's say, Solana position. And if Solana reaches certain price threshold, the policy condition is met, and this threshold or this part of Solana gets sold, which means you do not have to be present because the signature happens inside the enclave. So you no longer have to sit there and manually sign, but you can program it and it's automatically executed. Now, going one step back, connecting this to the Earn service, which I was mentioning, due to composable policies and these two services being in the close proximity within the Flex Vaults, what you could essentially do is say, not only that you are selling my Solana profit into USDC, but I want you to grab this USDC and immediately route it to passive yield. So it all becomes very programmable, and obviously we are building a UI that will enable this on top. One more cool use case. So a lot of people today are trying to build trading bots or CloudBot or OpenClaw, however it's called. And often we would see private keys, either straight in the code or some sort of environment variables or some sort of backend. Now, if we think about the architecture I was displaying before, what you can do is you encumber a new private key on Ethereum, and then with policies you say you can only trade $50 a day, or maybe you can only trade while I'm working, etc., etc., and your CloudBot never gets access to the private key. So you just created essentially a very neat middleware which the bot can access over API, but you still stay in the full control over programmable policies. One more use case worth mentioning, if anyone here is non-DeFi but more gaming related. So Web3 gaming, where actual assets are getting spent in-game to buy different assets, require user signing. What we already built in FlexVaults SDK, and this one is internal testing, is where users can enter the game, set a certain threshold of spending and the time frame, and as they are playing the game, policies will sign until user reaches the threshold. So to put it very plastically, you could say, I'm allowing $50 to be spent in the next 5 hours, and while you play, signatures happen automatically. You are buying in-game assets without even realizing due to the FlexVaults and policies. There are multiple ways these primitives can be used. I touched already some of them, but to make this not too long, I think I will conclude. So access is not an instruction, it is an instruction, not a compromise. And what we're building has to be programmable, it has to be private and permissionless. Thank you very much for listening, and I will be around for questions. I don't think right now is a good time. So yeah.